Okay, let me elaborate on this alternate or alternative hypothesis, again, also known as the scientific hypothesis. That states that there is a change, a difference, or a relationship for the general population of people that tipped under the red shirt condition. In the context of an experiment, this alternative hypothesis predicts that the independent variable does have an effect. So let's look at the expression of these. And by the way, I'm oversimplifying here. We're speaking right now only of quote unquote two-tailed test. What do I mean by that? Let's take each hypothesis individually. The first hypothesis says that the mean tipping rate under circumstances where the staff is wearing red shirts is 15.8%. What that means, it doesn't make any difference. Even with a red shirt, it doesn't deviate from the baseline. The alternate says it'll be different than 15.8. And what does that mean? Well, the implication is they might even tip less than 15.8%. Now, is that an authentic research suggestion that we think tipping will be different and possibly less with red t-shirts? No. But this is an example of a two-tailed test. What we mean by that is that the effect of the independent variable, which is wearing the red shirts, could be that it reduces the dependent variable of the tipping rate, or it could be that it increases it. So it begs the question, why would we lead off with an inauthentic example? Because we have to explain the process first. It's seldom the case in the real world that we have a bona fide two-tailed test. Generally speaking, the researcher would have it in mind that it would increase tips. However, in this case, we're going to just open up rhetorically with a two-tailed test, and every textbook does it the same way. We have to cover two-tailed tests first, and then we'll get into maybe the more authentic one-tailed test. But I want to say something else right away. How can you tell it's two-tailed? The symbol use will give it away right away. The null will say equal, and the alternate will say doesn't equal. That's it. They're opposites of each other. It's always two-tailed if the notation looks like that. So that's just sort of a rule of thumb. So if you'll indulge me in more reading, and I know you're probably getting annoyed with me already, but I really feel like I want to walk through this so slowly because this is the way that I was taught, both as an undergrad and as a grad student. We're going to ask a question. We will ask a question. What's the probability that we obtained a sample mean given that the null hypothesis is true? If that probability is very low, we're going to make a ruling. And the ruling is the probability that we obtained a sample mean, given that the null hypothesis is true, is so low that we'll declare that the null hypothesis is not true. We're going to reject the null hypothesis, which is what we want to do, and enjoy statistical significance. That's what we want to do. Normally, rejection, you think of it as in a romantic context or something like that. And rejection hurts, and that's why we have country music. In this case, we're rejecting the idea that it had no effect. And I want to reject that idea that my independent variable had no effect. So, and that's what we know as statistical significance. So what's the probability that we obtained a sample mean given that the null hypothesis is true? If that probability is low, we're going to make a rash statement. And the rash statement is that the null hypothesis isn't true. And you can think of that, isn't that the way jury trials work? If I'm evaluating a defendant that may have committed an awful crime, I ask myself, what's the probability that we had all these eyewitnesses? What's the probability that they had that physical evidence and the guy's actually innocent? If that probability is terribly remote that all of those things are true and he's actually innocent, then I might make the declaration that he's guilty, if you will. Conversely, let me go to the next paragraph. If that probability is not particularly low, we're going to make a ruling that the probability that we obtained a sample mean, given that the null hypothesis is true, is not particularly low, and we will thus accept the null hypothesis is true. We're just going to have to live with it. We will fail to reject the null hypothesis, which is a bummer. We prefer to reject it. We will not enjoy statistical significance in that case. So it begs the question, how are low, quote unquote, and not particularly low determined? This is a magical thing called alpha, and we're going to get into the mechanics of that in the next clip.